true strength comes not from standing alone, but from standing together. That very spirit of Ubuntu, collaboration, resilience, and community is what inspired our project. Good afternoon, everyone. A warm welcome to this event. Thank you, UbuCon Asia 2025, for providing us this platform to represent ourselves. My name is Dipesh Poudel, here representing Cloud Himalaya, a pioneer in secure digital infrastructure and Nepal's Tier 3 equivalent data center. Together with my colleague, Mr. Sushant Prasai, I'll present you how we fortified Ubuntu's CIS benchmarks through automation with Wazuh and Ansible. Over the next few slides, I'll take you through the origin of the idea, our vision, our process, and the results. Let's get started. As we all know, every innovation has a beginning, and for us, it is the Cloud Himalaya. Cloud Himalaya is more than just a data center. It is a landmark for innovations. And every employee here is encouraged to pitch an idea. And if it has remit, it will be taken to a full-fledged production environment. The core value of Cloud Himalaya has made this project a propitious one that you'll see unfolding today. Before diving right into the project, let me share you about Cloud Himalaya. Cloud Himalaya is a data center. It's a Nepal Tier 3 data center, and we have been providing services since 2013 AD. With ISO 27001 to 2022 certification, redundancy across all systems, and the ability to withstand a 72-hour power outage, we epitomize resilience. Our services run 24/7 with 99.982% uptime, supported by ITIL framework. As you can see, this is the domain coverage of Cloud Himalaya. Cloud Himalaya contains varieties of customers like ISPs, fintechs, institutions, and other services providers that doesn't withstand any outage or breakage. So Cloud Himalaya has been servicing for last more than a decade. These are the major clients of Cloud Himalaya. The reach is diverse and far-spanning. It provides services to enterprises like Kantipur, major banking services like Jyoti Vikas Bank and Mahalakshmi Vikas Bank, and other service providers like AG, CityPay, and Synergy Tech. Our vision was simple but propitious and built a system that automates CIS control enforcement on Ubuntu. Our mission was sharper, ensuring integrity checks, securing SSH parameters, and fortifying infrastructures against modern threats. With Wazuh, we could detect configuration drifts, vulnerabilities, and anomalies in real time. With Ansible, we could automate fixes and reduce response time to under 2 minutes. And with integrated alerting, we enabled to collaborate team faster. The mission was to make compliance not a burden but a seamless safeguard. Here are the results. And as we all know, numbers always tell a powerful story. Over 200 CIS benchmarks, CIS checks were enforced automatically without manual intervention. Nearly 1,500 vulnerabilities or anomalies were detected in real time, showing the sharpness of our monitoring. Our mean time to detect was just 1 minute and 45 seconds. Mean time to respond was 1 minute and 50 seconds. These numbers are not just statistics, they validate the power of automation. What used to take hours or days now takes minutes. And that's where the real impact lies. Faster detection, faster response, and stronger security. Our process was systematic and streamlined. First, we mapped CIS benchmark controls into enforceable tasks. Next, we used Ansible playbooks to apply secure configuration and lock down critical parameters. Next, we used Wazuh SIEM continuously monitored systems for drifts or anomalies. And finally, automated Ansible workflows corrected misconfigurations instantly. This synergistic loop meant compliance was not a one-time activity but a continuous cycle of check, detect, and remediate. The process blended automation, intelligence, and collaboration into a resilient framework that could adapt as threats are evolved. This mind map captures about everything comes together. On one side, CIS benchmarks provide the foundation. On the other, Ansible ensures consistent enforcement, and Wazuh SIEM correlates logs, detects anomalies, and visualizes risks. Together, they coalesce into a cohesive and self-healing ecosystem. That's the two paradigm shift here, moving from reactive security to proactive, automated, and intelligent security. This framework doesn't just protect Ubuntu, it fortifies it. Now let me take you into a project breakdown. First, we access an interactive web interface that is deployed through Fast API layer. And through that Fast API platform, we automate cluster deployment with the help of Python. And this automated cluster deployment is possible through URL hook of Wazuh API. And after automating cluster deployment, we can manage cluster, that's for obvious. And after the installation of cluster, we can install agent as well. But the thing is here, aside automation, we can also use manual installation as well, following the Wazuh proper documentation. And as we all know, or we might not have known about it, but after the installation of Wazuh agent, it captures all the informations and all the logs and all the changes inside operating system, that is Ubuntu, and it sends logs to Wazuh server, and that logs contains CIS benchmark assessment, and Wazuh by default declares some CIS scores from 0% to 100%. So whenever we install Wazuh agent on Ubuntu operating system, the CIS score can be visualized, and by default it is around 40% or 45%. But here we have made it up to 70%. After the assessment of CIS benchmark, Grafana comes into play. Grafana visualizes every logs, every changes that any user or external user commits inside the operating system after accessing it. After the Grafana visualization, there comes real-time event monitoring that is done by Wazuh itself, and we have deployed Wazuh server in a single node, that is Ubuntu itself, a Wazuh agent on another node with the help of Ansible on that is separate node VM Ubuntu agent, and we have installed Grafana on the Wazuh server through the help of Ansible. So everything works here with the help of Ansible itself. So Ansible here works as an automated platform. So far we have visualized, or we have gone through the process, vision, and the project breakdown. Now for the heart of the implementation, I would like to hand it over to my colleague Mr. Sushant Prasai. He will guide you through the heart of the implementation.
Hello everyone, thank you Dipesh. So now I will walk you through the inner working in the outcome we achieved. As he mentioned, this is the heart of our system. The Wazuh agent on the Ubuntu feeds events and log to the Wazuh. The data is sent to Grafana, which visualizes the data. And then that graph is embedded in our application. Our application also queries Wazuh API for compliance detail. And based on that information, Ansible playbook is triggered, which performs CS automation on the Ubuntu. Now, while setting up, we can either integrate existing Wazuh in our system or deploy a new one. As a manual deployment of Wazuh can be tricky, so we have automated the entire process. We can either deploy in a single node or multiple node for high availability and scalability. And based on the option we choose, we have configured an Ansible playbook for that process. For Wazuh agent installation and CIS automation workflow, first of all, the system prompts the SSH credential of the target server. And then Ansible pushes the agent to the Ubuntu, which then sends data to the Wazuh. And then that information is retrieved by our application, which checks if CIS remediation is required, and if yes, then it performs the CIS automation. Now this is the outcome we have achieved. Through Ansible, Wazuh agent has been added in the Wazuh, and it continuously reports to the Wazuh for real-time monitoring and threat. So as we can see here, before CS automation, the score was only 45%, and after it has increased to 70%. In Wazuh, only the checks are listed, but there is no any fixes or remediations. So we have used Ansible for those remediations. Some of the example of CS benchmark we implemented were systemd zonal remote authentication for remote logging, sudo timeout for to limit privilege of use, and reauthentication are among some of those. And as you can see, there are still some of the failed checks, and that is left intentionally. Our aim was not to develop a hardened Ubuntu ISO that is already available through ready-made image. But our focus was on enforcing CS compliance on already live and running Ubuntu system that contains data. So as you can see in the image, some checks like partitionings and corner levels are left intentionally so that we don't affect the system stability and integrity. And the handy part of our system is also, anytime we deploy an Wazuh agent, the Grafana graph is automatically created. Now let's see the demo for first proof of concept application we deployed. As it is a POC, it still has few rough edges and it's not perfect, but it still demonstrates our core idea. Can you please play the video? The video is in presentation. So we are here deploying a single server cluster. It step by steps installs all the components needed for Wazuh. And then we can access the Wazuh using the IP we provided. Now, as there was source for single server, here we have a setup for multiple clusters. Here we can input as many as managers and indexers, and based on that, high availability for scalability reasons will be deployed. Now, this is a demo for Wazuh agent edition. Can you please play the video? Excuse me, can you please play the video? So it's a simple step-by-step process. Now, finally, performing CS automation on the newly added agent. This is also a video. This is also a video. You can play this. So as I mentioned previously, the Grafana graphs are automatically created, and we can see the compliance details. And once we perform CS automation, it will perform all the, we can skip to the end of the video. It is a very long process. Now, as you can see, from 45 to we have increased our CI score to 70%. Now, I would like to hand over to my colleague Dipesh for further presentation.
The outcomes were remarkable, but the future is even promising. On this slide, we can see that it is a SWOT analysis. SWOT represent strengths, weaknesses, threats, and opportunities. As strengths, we have deployed we have deployed automation and monitoring with automation. That is our strength. And for weaknesses, the weaknesses can be considered as a catalyst for improvement, not for demotivation. Weaknesses were visualized as misconfigurations during the installation process, and Ansible threw plenty of errors, and we were anyhow able to tackle it. So those were the weaknesses of this project. For threats, every second we have been receiving plenty of logs. If we move on to Wazuh dashboard, we can see plenty of vulnerabilities and threats they are displaying on the Ubuntu system, and those are the threats that we need to tackle down, and we need to remediate it. And for opportunities, there are zero-day threats. That is our main goal. The major goal is to achieve Ubuntu that is more secure and resilient. So, future improvements can be considered as stronger automation. Instead of Ansible, we can just move into CI/CD pipelines that contain GitHub Actions, GitLab CI that automatically validate and deploy ordering rules. Also, automated testing and rollback can be done in the future. As this is our nascent project, we will be working into it further. So we have mentioned it inside the future improvement. For alternative tools, Safe and Puppet can be used. Safe and Puppet are used because they are the automated alert management and compliance check tools. And for Splunk, instead of Wazuh, we can use Splunk. Splunk is an advanced monitoring tool, and it also detect, calculate, and evaluate every threats and vulnerabilities existing inside operating system. That is Ubuntu. And moving on, self-healing infrastructure. We can enable auto remediation, where Wazuh alerts trigger Ansible playbook, and Ansible playbook just pushes the directory where operating system can be remediated through the CIS compliance checks. In a nutshell, we may move beyond compliance check. We may have to look into the configuration folder and files of bootloader or graph.cfg folder file. During the boot of the operating system, bootloader may be hardened as well, which would automatically prevent the Ubuntu from being attacked or vulnerable. So that was our journey. So if you have any query, you may ask, and I would accept your query, your critiques, and your analytics as well. If there are any queries that you may want to what? You may be asking about Wazuh or Ansible as well. Okay. After the installation, let me create a scenario. We had 3 Ubuntu ISO, and in one of the ISOs, we deployed Wazuh server through the Ansible. That Ansible was deployed in a single node VM, that is Ubuntu, and through that Ansible we deployed Wazuh and another node, that is another VM ISO, and through that Wazuh server we deployed Wazuh agent. Now Wazuh agent calculates CIS score of the operating system. That is, CIS means Center for Internet Security, that is compliance. Whenever we have CIS score below than 40%, we may be attacked. For an instance, a Windows server ISO is always compromised because it has CIS score of below 25%. Now, our main goal here was to increase the CIS score. CIS score increment means to harden the system. And to harden the system, Wazuh by default gives CIS remediation. For instance, if we have ISO password for 30 days, Wazuh by itself gives the remediation that it should be elongated or it should be changed. So those are the remediations. And we worked on remediations, and we created Ansible scripts, and we ran them on Wazuh Ansible nodes, and through Ansible nodes we extracted code into fast API layer through Python, and that fast API layer automated the CIS automation through which the Wazuh remediation were improvised and were deployed into the Wazuh server, and that is how the Wazuh agent got high score of CIS. Yeah, Wazuh and Wazuh agent as well. Yeah. Your Wazuh recommended CIS compliance checks remediation, and on the basis of remediation, we implemented those remediation on Wazuh Ansible script, and we ran them on Ansible node, thereby increasing the CIS score.